Today's topic is going to be section 4.6, which is about triangle congruence, CPCTC. This is another way that we can sort of prove some of these theorems and use them to sort of help us prove that triangles are congruent. We're going to start to see that some of the ways that we use these to prove that triangles are congruent are going to help us solve real-world problems. So let's take a look at this. CPCTC is actually an abbreviation that means corresponding parts of congruent triangles are congruent. It's just like what we've been talking about. When you have two congruent triangles, the pieces are the same. Okay, and so that's as corresponding parts of congruent triangles are congruent. CPCTC. Let's look at one of those applications I was talking about. This is an engineering application, and a lot of times with engineering and things like that, we're looking to solve simpler problems. And so what I've got here is I have a bridge drawn on here. Now you're thinking, well, what kind of bridge is that? I'll show you here in just one second. Let me label these. And the bridge is actually just this part here. Guess it's kind of hard to see that blue. But this is the bridge right here. Let me mark it in green. Okay? But what we've done is we've said we want to know what the length of the bridge is, but we can't necessarily know that because we can't measure it. Because it's hard to get across that canyon. But what we have done is we've said, what if we solved a simpler problem? What if we solved a different problem? And kind of tried to figure out what exactly it was that we were looking at. And so what we've done is we've set up a series of triangles here, and I've gone to point C, okay, and I measured 500 feet out to get to B. I've also measured 500 feet out to get to D. And something else that they give us is that this is 600 feet. Okay? Now, what we've done is we found these figures to the end that we can see certain relationships develop. Let's look here. If I have, basically I have triangle EDC and triangle ABC. And what I'm going to try to do is show that these are congruent. Well, let's look. We know that DC is congruent to CB, right? Because they're both 500. Okay? We also know that angle DCE is congruent to angle ACB because they are vertical angles, right? We also know that angle D is congruent to angle B because they're both right angles. And so what that gives us is an angle, a side, and an angle congruent to an angle, a side, and an angle. So what we can say is that triangle EDC is congruent to triangle ABC by angle, side, angle. What does that mean? Well, that means that DE or ED is congruent to AB because CPCTC. These are congruent triangles. So because they're congruent triangles, that tells us that those parts must be congruent because they're corresponding. So this over here is congruent to this over here. So that means that AB is equal to 600 feet. It's a pretty long bridge. I didn't have to measure across a canyon. I didn't have to use a helicopter. I didn't have to defy gravity. I simply used congruent parts of congruent triangles. Okay? So, here's another one. And what I'm going to do is I'm going to draw on this pond here because I've said that we're measuring the distance across this pond. And so, just so you know that it's a pond, I'm going to add a little foliage in here. Okay? Maybe I'll add a little duck here. And of course he's got to have a beak, right? Okay. And so there's a little duck. This is a pond. We want to measure the distance across the pond. Well, we're going to do a similar thing here, because what we know is that we have a side congruent to a side, another side congruent to another side, and this angle is congruent to this angle by vertical angles. So we have side, angle, side, side, angle, side. So we know that triangle MN, we'll call this point L, is congruent to triangle KLJ. So that means that MN is congruent to JK, MN, JK, see, JK, MN, JK. Oh, I listed these backwards, sorry. This should be ML, MNL, it should go J, it should go KJ, KJL. So MN is congruent to JK, so that means that JK is equal to 41 feet. Because it's a congruent part. It's a corresponding part, so it's a congruent part. So if I drew this distance across here, it's going to be the same as this bottom part. This is great for us because we can use these corresponding parts to prove that certain things are congruent. Let's look down here. This is a little proof. And what they've given us, I'll just go ahead and mark on the diagram. AB is congruent to DC, so they've given us this. And they've also said that ABC is congruent to DBC. This should be DCB. Sorry about that. Okay, so these two angles are congruent. Well, let's look at what we've got. Basically, what we're going to go through and say is we want to say that A is congruent to D. Well, let's look here. What do we have? It looks like we're going to have like a side, an angle, and a side. So let's say AB is congruent to DC, and that's given. Okay? Also, angle ABC is congruent to angle DCB, also given. And what we can say is that BC is congruent to BC, and that's the reflexive property of congruence. And so we know that that's a side, an angle, and a side congruent to a side, an angle, and a side. So what we can say is that triangle ABC is congruent to, and it goes A, B, C, to triangle DCB, because we used side, angle, side. And so therefore we can say that angle A is congruent to angle D by CPCTC, because this says that if the triangles are congruent, then the corresponding parts are congruent. Okay? It's that easy, guys. So if we can prove that two triangles are congruent, then we can say that their parts match up. Let's try one more. Here's another proof. They've given us EG and DF. So EG parallel to DF. And they've also given us that they are congruent. So this is what we have. So we're going to prove that ED is parallel to GF. Well, let's look. If we have this side, okay, something that we can say is we're going to go ahead with our given. So we're going to say EG is congruent to DF. And these should have these segment marks above them, guys. All right? That's given. Also, it looks like maybe we could use the fact that EF is congruent to EF, because that's an easy one. That's reflexive property of congruence. Okay, so that's an easy one. That helps us out. Now, we have a side and a side. is there a way that we could prove this angle in between them is the same? That's what we're trying to figure out, because if we can prove that the two triangles are congruent, then we can prove something about the parts. So let's see this. What if I said angle GEF is congruent to triangle DFE? Because they are alternate interior angles. Okay? And so because they're alternate interior angles, what we can say is that triangle EGF is congruent to triangle FDE. Okay? So that's what we've got so far. Because we can say side, angle, side. So this is by side, angle, side. And so if I'm using side, angle, side, now I can say that these two triangles are congruent. So triangle 1 and triangle 2 are congruent. This is good for us. Because now what we can say is if we could prove that these angles here were congruent, we could say that these lines are parallel. So ED and GF, which is what we want. Okay? So now that we have these two triangles are congruent, 1 and 2 are congruent, we can say that angle EFG is congruent to, so it goes EFG, we can say that that's congruent to angle FED, because that's a corresponding part of congruent triangle and it's congruent. So now I can say that ED is parallel to GF. Why? Because this is the converse of the alternate interior angles theorem. Okay? So because these two sets of angles are congruent, I can say that these are parallel to one another. Okay? That's actually a slick little proof. Now, I've got two more proofs for you. They're going to come in another segment of this video. So this is part 1. You can watch part 2 for these two proofs. Thanks for watching this part, guys. We'll see you on the next part.